double check the attendance for first period. If there's any issues, please call the office 2196 or 2197. Thank you.
Hopefully those are in. I'll look at those later. I thought you did a good job of working. There'll be a couple performance tasks you do on your own, but the first couple we like to do as groups, so it should be good. Okay. All right, cool. All right, we have our kicks of the week from geometry. Okay, these are Catherine's. These are nice. You're doing a great job with the kicks of the week, and by that I mean just keep wearing shoes. Keep wearing shoes. At some point I'll notice. Okay, pretty good job. Okay, have a conversation about the question on the board. Make it work. If it's a ghost, you should be able to see through it. All right, what is it? Yay? Nay?
Yay!
And why does it not look like that? Anybody want to raise their hand? Tell me, Cora.
Because like the black and the white blocks kind of like make it look like this like shift makes it look like yeah.
It's an optical illusion. It makes it look like it's not, but the squares are like slightly tilted. In fact, I do have one of these lines right here actually, and if I bring it down, these are all good. Okay? It is trippy on a Monday. Okay, now if you take the squares, what some of you probably noticed is they kind of just like gradually like tilt them up a little bit. Okay, but the lines themselves are actually parallel. Okay, cool. That's what we're going to talk about. Okay, some of the stuff we talked about today, you're going to think we did last year, but we really didn't. You'll see what I mean. Okay, let's see. You've got 1, 2, 3, 8 warm-up questions on that page. Go for it. Let's go. Come on. 8 of them. Thrice. Hopefully somebody knows what thrice is. All 8 warm-up questions on that page. Go on. Thrice.
That means like three.
Once, twice, thrice. Beyond that, I don't think there is anything.
This is the equation. Go sit next to Brady.
You should know everything on that page.
Okay, I got it. It's 65. We don't want 65.
First one.
No, I got it for you.
Alright, what's 65? No. Oh, we got
That thingy. Anybody get the measure of angle 1 to be 65? You actually don't have to find the other one, but it's 25. Thrice. Thrice is 3 times. Once, twice, thrice. I don't think there's anything for 4. Usually that's usually what happens. Somebody goes like thrice or something. Good job. I don't think that's right, but whatever. Keep going. I'll be surprised no one else tried it. What?
For number 4, it says a plane contains oh, fine. Never mind.
Cool. Good talk. Anybody get 80 and 100 for the second? Yes, I know it's Monday, but you should still be past that second question. Please don't take that home. We just did a bunch like it. If you're not sure how to do it, I have it on the board. Then you have a bunch of true, false, and some circle.
That's what it says. Infinite.
Did he say finite?
It's finite.
No, it's not finite.
It's finite.
He said 50.
Fin?
I thought it was finite. No, go sit next to me.
What? They did. Did the Dolphins lose yesterday? Yeah. It's bad. And they stopped throwing it to him. You should be finishing up. Let's go.
That just does not spell fine. Present.
Okay. Now I'm just going to pick people because some of this is chapter 1 stuff and some of it is not. Okay, this is true, false. You can name a plane by a capital letter. Let's go with Eddie. True, false? It is true. You can just have a plane like this and just name it like plane P. That is possible. We don't see it a lot, but it's possible. Okay, a plane contains a finite number of lines. Jack.
False.
Okay, good. And it's not finite, is it? It's not finite. Just clarifying for your table back there. No, there's an infinite amount. 2 points lying on the same plane are coplanar. Caleb. That's true. And if 2 distinct planes intersect, then they intersect in exactly 1 line. Ellie. Also true. Okay. You're going to see some of that chapter 1 stuff come back. Now remember, when we learned this stuff, we called them terms that we're going to use to define everything else. So plane, lines, all that jazz, it's all coming back. Circle the segments that are parallel to the x-axis. Okay, little yay or nay. Cool, which means the other ones are parallel to the y-axis, correct? Okay. Now I don't know, I think this one might be on the next page. I didn't tell you you had to do it, but I'd be curious. Circle, you should be able to answer this on the fly, even if you haven't looked at this question yet. Circle the polygons that have 2 pairs of parallel sides. Another round of yay or nay. Yay. Good, it only has 1. Now, there are like these horrible definitions of trapezoid out there that say they have at least 1 pair of parallel sides. Just confuses me. A trapezoid has 1 set of parallel sides. Otherwise, it would just be a parallelogram. Okay, cool. And then the last couple. Okay, again, on the fly, shouldn't be too bad. Okay, a blank consists of 2 endpoints and all the points between them. That would be segment. And a line is made up of an infinite number of points. Little reminder, you had a slight break from this in chapter 2. Slight. Please don't forget that notation will come back to haunt you. Line segment with the little segment above. A line, you need to indicate that. Okay, and also with array. Yes, you could write the words, but you're going to be writing enough words this chapter. But remember, that notation does matter. You didn't get it as much in chapter 2. Okay, you will get it all back. So a lot of these definitions we have seen, so I want to breeze through them very quickly. Your definition, parallel lines, coplanar lines that do not intersect. Why do we need to indicate that they are coplanar? Does anybody know? Jazzy? Because skew lines are not parallel. Does anybody remember what skew lines are? Elena? They're lines in different planes that will not end up intersecting, okay? So if I looked at that like cube right there, there's a lot of lines that are parallel. Can somebody just give me an example of parallel lines? Just one. There's plenty of them, okay? Conlon. So line F, G, which is right here. What was the other one? We like that as an example? I do. Now, again, we could keep going, but we're not going to. You'll get there in just a moment, okay? Those are parallel lines. There's other pairs, okay, and then we're good. Skew lines are any non-coplanar lines. So there's plenty of skew lines on there. They're in different planes. They won't intersect. And even though they won't intersect, we wouldn't call them parallel. So if you look at that diagram right there, okay, I know it's small. Are A, B, and C, D, are they going to intersect? No, not at all. But would you call them parallel? Not really. You all know what parallel lines are. Those are skew lines. Okay, there's plenty of them on there. Okay, who can raise your hand and give me an example of a pair of skew lines on that cube? There's tons of them. Tons of them. Layla. And what? DA. So DA, which would be right there. And again, I got my line notation. And what? EF. I like it. Now again, if you're thinking, well, I have a different answer, it's possible. Okay, we're just going to list one of them. Eventually, you'll have to list like kind of all of them. Okay, and then what's your last definition? Parallel planes, any planes that do not intersect. A good bit of this got covered in chapter 1, but we need these terms so we can do other things, which is what we're going to focus on in chapter 3. Okay, so once you've written that, what I'd like you to do, and this one's tricky, this takes a minute. So it's not going to be like a, 10-second thing. I want you to complete the rest of the page. Okay, you're going to put each term, word, phrase, or symbol in the correct oval. Okay, if you need to use it more than once, you can. If you don't use it at all, that's also okay. So that's like a word bank. You might use them all, you might not. You also can use them more than once. So I want you to use that same picture, put these in the proper ovals, okay, and there's also questions beneath that you can look at. This will take you a couple minutes. I don't anticipate 10 seconds of work. I would encourage you to talk about it with somebody if you want.
So which picture are we using for the line?
This one, right here. This one, right here. You'll know. This picture right here. The ovals are that picture, the questions below are that picture. Yeah, you can write that one.
He said he was
Talking to me? I'm him. If it doesn't apply, we'll write it off. Not what he said.
No one wrote.
Hey, did I get that right though? I'm him, based on that.
Yeah. All right. You're such a silly. Yeah. All right. Here's the H.
You like our tree? Seconds from
It's parallel plane H.
Another minute or two. A lot of you are working on the last one.
No, but they're here.
That's mine.
There's a plane that.
Because, no, they can be on the same
If
page.
you write for
Last minute, then we'll check the ovals, and we'll talk about that last diagram. Okay, before we start going through the ovals, one of those words did not get used at all. Which one? Good. That one did not get used at all. That's what he said. That's just funny. You were telling me that's what he said when I was the he. Okay, cool. Question: did any of them get used in multiple ovals? What, Sawyer? Okay, do not intersect should be there, and do not intersect should also be there. Okay, that's why I gave you that direction. I don't think any of the other ones do. Okay, so anyone want to tell me anything else that ended up in parallel? Anything that ended up in parallel? Okay, Grace, what did you get to put in parallel?
Coplanar.
Yeah.
AE.
Sorry, yeah. Good. A, E, and C, G, and then I will put line notation right there. Keep in mind, you can always put the word line in front, but you're going to get sick of that really quick. Okay? And then skew should be non-coplanar. Mine don't really fit. And then BC and then AE. Okay? Not too bad. Now let's talk about this particular one. Okay? Some of them only ask you to name one, and many of them ask you to name all of them. When I say which segments are parallel to AB, I need all of them, not just one of them. Okay? So let's actually start with it. Let's identify AB. And these are all segments. Where's AB? Is it? Yeah, get out of there. Okay, cool. Hold up the number of fingers of how many segments you wrote down. If you wrote down one, just write two. Hold on. Ooh, a lot of good ones right there. Okay, good. Some of you did write down one, and then I think you went back and you added more. How many of them are there? There should be three. Okay, Ronan, what do you got? Oh, you held up a three. Did you hold up a three?
No, I was showing two.
Oh, you're showing two? Who's got three then? Who's got all three of them? Okay, Elena.
Segment GH and DC and EF.
So there we are. So C, D. The order of them doesn't matter. Like I heard the two of them arguing at EF versus FE. It doesn't matter, okay? And then GH. All parallel. I mean, again, you don't need to say that AB is parallel to itself. Yeah, don't bother with that. Okay, cool. Pair of parallel planes. You could have either done the top and bottom, the front and back, or the right and left. Okay, remember, you need at least three letters. I just did all four. So I did plane A, B, C, D. What would A, B, C, D be parallel to? That was just one of them, okay, but there's actually three of them. Which segments are neither parallel nor intersecting with AB? Should be a couple of these. One person. Nicholas. BH. Say again. Yeah, mine are in a different order. Yeah, and? He. And? There you go. Cool. Okay. And why are F, E, and C, D not skew? So if I backtrack to this, F, E, which is that back edge right there. So F, E is right there. Okay. And C, D, why are they not skew? Yeah, they actually are. They're parallel. They're actually coplanar. I think you've made a lot of progress with the plane stuff. You think back to that stuff a couple weeks ago, and some of you think your heads were spinning a little bit, but now you're starting to see it a little bit better. That's just a comfort thing. Okay? And then two segments that are parallel to DCGH. I mean, there's actually plenty of them, so we can kind of cruise right past it. Okay, cool. Now, let's get to stuff that, if you remember from last year, you're probably going to be like, I saw this and we did it, but it's a little bit different now. You'll see why. Okay, does anybody remember seeing that word last year at all? Cool, great. Okay, transversal. I know you did this with Miss Galbraith. It's just a question of what you remember. A transversal is a line that intersects two or more coplanar lines at distinct points. Now to show you a picture, I think some of you are going to remember it. I actually have the results to prove that you did see it, but trans means across. It's a prefix. So this transversal is cutting across these lines. How many angles is it making? 8. Okay? We have some on the inside, some on the outside. Is this ringing any bells? You could say no. Does the picture ring a bell? It's not making 9 angles. It's making 8 angles. Not helpful. Okay? When you see the diagram, I think some of you will be like, oh, I kind of remember doing this stuff. But the T is for transversal. Okay? You have your 2 lines. Okay? You're creating 8 angles. Now, last year, these were the diagrams you saw. Someone's got to be like, yeah, I remember this now. Okay? You actually did a great job with these questions. These were transversals, but last year, these lines were always parallel. They were. That's like the way the questions are designed. This year, they might not be parallel. Like today, they're not going to be parallel. And then eventually, this is what you're going to hate. By the end of the week, it'll be up to you to prove that they're parallel. I know, but we'll get there. Let's get through Monday first, okay? But this diagram looks familiar. We did do this last year. The lines were always parallel. They don't have to be. L and M are clearly not parallel. They're going to intersect. You can still have a transversal that cuts across, okay? So some buzzwords. We have alternate interior angles. Alternate interior angles. I think you're just filling in some blanks. Non-adjacent interior angles that lie on opposite sides of the transversal. So we're going to use this diagram for like all of them. I want you to, next to your definition, I want you to write down what pairs of angles do you think fit that definition, and then check with somebody. Write down what numbers in that diagram you think fit that definition, then compare with somebody. That's how we're going to do all these. Non-adjacent interior angles that lie on opposite sides of the transversal. Good high five. Now, rather than check them, let's do all the definitions, then we'll come back and check, and you can make adjustments as you need, okay? So those are alternate interior angles, okay? What's your next one? We did not talk about this at all last year, okay? Same side interior angles are interior angles that lie on the same side of the transversal. Same thing. Once you fill that in, I want you to write down any pairs that you think fit that definition. Check with somebody. Okay, we got 2 other ones we're going to do. Then we'll check them all. Then we'll see what adjustments we make. Same side interior angles. Okay? Next one. What's your next one? Corresponding?
Yeah.
Corresponding. These are angles that lie on the same side of the transversal and are in matching positions. Then what I'll do is, how about I give you the fourth definition, and then you can go check all of them and see what you like, okay? Those are corresponding angles. Same side of the transversal. We say they're in matching position. What's the last one on your list? Okay, you wouldn't be surprised. Non-adjacent exterior angles that lie on opposite sides of the transversal. So now that you have all the definitions, why don't you now converse and say, okay, which pairs fit all those definitions, then we'll check them all. So once you've got that definition, why don't you see what numbers you have for pretty much all of them as pairs? Then we'll rendezvous. Last. You should be writing the numbers just like right next to the definition. Yeah, Nick. Go ahead. As many of them as you can come up with.
So like this, it's 1 and 5. Yeah, wait. What about 4 and 8? 5. What about 4 and 8? 7.
We'll use the vertical angle theorem a lot, don't worry. That's why it's allowed to be abbreviated. It's going to be a large part of our proofs. Make your final selections, check them. Exactly, that's why it's a waste of time. Be ready, I'm about to pick people too. Make your final choices. Alright, it's time. Let's see, alternate interior angles. Sarah, what do you think? 2 and 8. Okay, do we like 2 and 8?
Yeah.
Gotta answer that. Everybody likes 2 and 8, then what would the other pair be? 1 and 7. We agree?
No.
Then you gotta give me an alternate. Lily?
4, 5, or no, 4, 6, 5, 8.
Interior. Interior. Interior is in between the lines. 4 and 6, 3 and 5. Okay, now anybody that's thinking ahead, what did Sarah just give me? She gave me alternate exterior. That's 1 and 7, 2 and 8. Okay. Alternate means they're on opposite sides of the transversal. Interior is why I showed you this diagram. Interior means they're located in between the lines. Exterior means they're on the outside. Okay. So now with that knowledge, I'll come back to this question. Okay. Same side interior. Let's go CC. 4 and 5, 3 and 6. If you have to make any adjustments, do. Otherwise, you're just checking them off. Okay, so interior still same side. We didn't ever talk about these last year. It never gets covered with the 7th grade stuff, and I can tell you why. Corresponding, these ones are a little goofy. Casey.
4.
Beautiful. Okay. They're in the same relative position. Okay? To correspond just means exactly that. So like if you look, this doesn't apply to all of your seats, but like right now, if I looked at a couple tables, like Ellie corresponds to like Ryan. See how they're like in the same relative position? Okay. Marissa corresponds to Jazzy, corresponds to Benji, etc. If they're in the same ones. That's what it means to correspond. It's like the top left. 1 to 5, 2 to 6, 4 to 8, 3 to 7. Now last year, pretty much all these were congruent and we were like cruising, but those lines were parallel and these ones are not. Okay? So now you have this knowledge, decide on what the answer to the multiple choice question is on the board. I don't think you have this one, I think it's just up here. All right, does anybody like A as in Ava? B as in Benji. B as in Benji? Yeah. You do like B as in Benji, 2 and 6. What's the other one? They didn't give it to us, but it's what, 3 and 7? Okay, cool. Sounds good. Okay, now this is where it can get to be a little tricky. Okay, questions like this are not stuff you're ready for in algebra, but you should be now. They gave you a very complex diagram right there. There are a variety of lines. There actually are a variety of transversals. It depends on how you look at it. And remember what a transversal is. A transversal is a line that intersects 2 or more coplanar lines. Okay, so what they gave you here, and I want you to really talk about this. They gave you an angle pair. You have to decide what lines and cut by what transversal create those angles. Then we have to name them as well. So what do I mean by that? Here's angle 2 and angle 3. You have to decide as a group which lines create those angles after being cut by what transversal, and then what would you name the angles. There's only 3 of them, but you have to look at it very carefully. Go ahead, work on that question. It's going to take you a minute or two. Don't be afraid to draw on the picture. What? Just try it, come on. Don't stare at me, so I'm not going to give you anything else. Work on it. And by the way, all these only have one answer. This is not a multiple answers kind of thing. And do not forget your notation. Do not forget your line notation. These are all lines. These are all lines. Gotta focus on these. These diagrams are like a lot going on. Don't forget to name them too. What are the name of the angle pair that made? Yeah, you gotta name the angle relationship. You have to name them. Like, what are they? Corresponding? Like, that's what it means to name the relationship. Yeah. Writing down the letters doesn't name them. That just identifies them.
2 and 3? Oh, okay.
Come on now.
They're same side.
Corresponding?
All right. Okay, so let's talk about these questions. You have to be extremely careful because you might pick a line and say, I've got it. It might not necessarily make that angle. You'll see what I mean. And by the way, these are not like, I got this answer, you got that answer, it's all good. This is like, it only works one way. I like to highlight on the diagram. I know that's not easy for you to do, but it is possible. Okay, let's start with 2 and 3. I actually think 2 and 3 aren't too bad. See, here's angle 2, here's angle 3. Okay, if I really need to create angle 2, I need you to understand something right away. That line is out. That's not going to create angle 2. That's what I mean by not all of them create what you want. Okay, so let's just go for it. Okay, I want takers here. It's okay if you get it wrong, but I'd rather not just be like, here's the answer. I want to hear what you have. Okay, who thinks they have the lines and the transversal? Then we'll get to the name. Okay, cool.
Lines PQ and SR.
So here, well, here's PQ, and then you said SR.
And then transversal QS.
Let's see. So the first thing you have to decide is, does that create the angles? Does it give me a chance at creating those particular angles 2 and 3? It actually does. So we should have line PQ. Do not forget your line notation. Okay, line SR or RS, it doesn't really matter. Okay, the transversal, SQ or QS, what's the name?
Alternating interior.
Nice job. How'd that first one go? I don't think the first one's that bad. However, you gotta see how it works. Do you know what I mean about if you drew in PS, it wouldn't make this angle? You have to really be careful. That's why we can't have just like a variety of answers. Okay, cool. Now it gets fun, at least for me. Okay, so now they want angle SPQ. So where is SPQ? SPQ is up here. And then angle PQR. Where is PQR? Is it right here? Is that 3 and 4 creating it? Okay, let's hear an answer here. Cora.
Are the lines about PS and QR?
Okay, so you said PS. So PS is right here. And then what? QR?
Yeah.
Okay. Well, our transversals would either be PQ, SR, or SQ. Which transversal did you say?
PQ.
Ooh, wow, we really went off the rails there, didn't it? Yikes. We were zipping along too. Okay, so we're talking, you said PQ, right?
Yeah.
That looks better. Okay, let's see. PS and QR. Transversal PQ. Identifier or name?
Same side interior.
Ooh, nice job, same side interior. How'd that one go? Yeah. Okay. Good. The last one, angle 5 and angle PSR. Okay. So angle 5 is hanging right here. And then what's that one? PSR. Where is PSR?
It's like 1 and 2.
1 and 2 combined. Okay. Now you might already know the relationship right now. That's allowed. Okay, but getting the right lines, everything is big. Okay, Ronan.
Are the lines PS and QR?
The line is PS. and QR. What's the transversal? Let's see. ES and QR, transversal. SR, name? Good job. Okay. Are these questions doable? Yes. Is it easy to get lost in the shuffle of the lines? Absolutely. Okay, so you have to be extremely careful. But also, the last thing you want to do is like lose points because you didn't put line notation on it. That is absolutely silly. Okay, questions about this one? Okay, good. The last question you have right there, it actually takes a minute as well. Identify all the angles that correspond with angle 6, and then identify the 2 lines and the transversal that form each pair. There's 4 blanks on there. That doesn't mean there's 4 of them. Or maybe there are.
There's 8, 2, 4, 14,
Whatever you say.
How is this?
Wait, does it have to be like in a relatively simple order?
That's a corresponding.
Okay. Wait, are you cooking?
Draw another line down there.
Say alternate state. Any of these directions.
What's this corresponding? Here, just stay
Make sure that when you draw it in, hey, make sure when you draw it in, you actually create angle 6. You'd be surprised. Some of you might write down lines in the transversal, and angle 6 doesn't exist.
We would have to put angle 6 in half.
It would have nothing to correspond. Yeah.
If you said that 6 is corresponding to 14, then what line do you
Again, make sure that angle 6 exists.
How does that?
A lot of answers.
Angle 6 is, it's right in front of you.
You're not in last
Can't just have one line.
Yeah, I don't want to touch
Line that you draw there that creates the angle. That's what we've been doing. The 2 lines and the transversal line. You have to identify what line is the transversal.
Guys, see me. See me or the line. Wait,
No,
guys.
but then it doesn't make it really.
Figure out what we're gonna do. There's a couple that we all agree on. There's a couple that.
Yeah, wait,
Wait, there's no line
Last minute, get your final responses.
It's not in a matching position.
Oh, we erased Stacy. Oh, you erased Stacy. No, nobody said they had the same measure. The only time they would have the same measure if you're doing A and B. All right, now let's talk about this. Okay, now one thing, sometimes your background knowledge gets in the way. Last year, you actually learned, I know you probably are saying you didn't do it, but I was here, even if I didn't teach it to you. Last year, you learned that corresponding angles were always congruent. Problem is, we only gave you parallel lines last year, by design, because the state only asked you about parallel lines. So the misleading part about this question for a lot of people is, people assume they have to have the same measure to be corresponding. That is not necessarily true. Okay, it's only true with A and B because A and B are parallel. The other ones are not. That is weird. You would actually be better off not knowing that corresponding angles were ever congruent. Okay, but there are a couple of answers on there, and then we'll talk about a popular answer that is an issue. Okay, I feel like just about everybody's got angle 2. Who's got angle 2? I saw angle 2 on almost every page. You know why everybody gets angle 2? Because of the parallel lines. A is parallel to B. Okay, your transversal is D. 2 corresponds to 6. That is like straight out of what you did last year. That's actually the first one I would expect you to all get. Has anybody got another one that they feel pretty good about? You feel pretty good about it. So the debates were all pretty good out there as well. Cole.
15.
I actually can't get on board with 15, which we'll talk about a little bit later on.
10.
I feel good about 10. Anybody else have 10? Now this is where it's annoying. But sometimes math is annoying. Sometimes life is annoying. Okay? So lines B and C, and the transversal is D. Okay, so where is D? Here. Here's why it's annoying. Because those are not equal to each other. And all the diagrams you've looked at so far, they're equal. But I promise you, all the diagrams they gave you so far, the lines were parallel. They're still corresponding. Okay? In fact, if I took this line C and I adjusted it, all of you would have said that. Okay? Did anybody have any reservations about picking something like that because they weren't equal to each other? That's your background knowledge getting in the way. Okay? You have to kind of let it go. Sometimes it actually hurts to have that background knowledge. Okay, so that one's good. Okay? It's actually only one other one that I can be convinced of on there. And it's not 18. Layla. It's 14. Lines D and C, transversal B. You have to draw it really carefully. I also need to turn the page to see it. I don't know if anybody else did that. But I drew in those transversals, those lines, and then that transversal, turn the page, they are. And again, it's annoying because they don't look the same, but they do correspond. Now, here's the only problem with 18. A lot of you want 18. Yeah, you can't draw in two, like what lines do you want to use to make 18?
Oh.
What lines does everybody want to use to make 18? A and what? A and B with transversal C. You never made angle 6. Angle 6 doesn't exist without another transversal cutting through those. You would need 2 transversals. So how many of you thought it was 18? 18 is a very good fake answer. You got the right idea, but look at this line. Angle 6 has not actually been created, so it has nothing to correspond with. Okay? If this extra transversal was drawn in, then yeah, 6 would exist, and then you can make a case for it. Right? But for some of you, if the biggest issue is like, they got to be the same length, you do have to let that go for now. The only time correspondings are given as the same length is if the lines are parallel or not. You'll see another one like this on the homework. I would encourage you to do one of two things. Either highlight the diagram, or when I do this stuff, sometimes I draw it off to the side. Drawing this off to the side shows I never created angle 6. Okay? Cool. You'll have a couple minutes. We're not saying 5 figures. Yeah. They correspond. Parallel universe right there.